again here. So I've restored my path by just copying it from the other shell. And that gets me back where I want to be. So now we're going to actually get into some actual Git. I think probably the first thing I'll do is to clean up my repo, because I've got some files in here that I was messing around with that aren't really part of where I want to go forward. So I use my aliases, alias GS, which is short for Git status, to see where I was. And yes, I've got some untracked files. So I could just remove them. I think I could also do like a git clean. And it wants me to make very sure that I want to get rid of stuff. So that also does it. Now I can see that there's nothing extra there now. Okay. Any questions before we go forward with the Linux stuff that I covered? I certainly didn't do it justice. It's very very powerful, sophisticated with what you could do with it. But if you do see odd combinations of vertical bars and greater thans and less thans and ampersands and numbers 0, 1, and 2, that's a signal to at least go Google IO redirection or pipes, or Unix pipes or something like that, and that should shed some light. Also, the bash man page will give you way more than you ever wanted to know about all that. So yeah, definitely lots there. Okay, so here we are. We're going to get into the 3 objects. There's 1 or 2 others, but I'm not going to really talk about those because they are variations of these 3. So content addressable file system. So that's the definition of Git, I guess, in a nutshell. And so we'll talk about what that is now. So here we are in our Git repo, and we can see what head is by using this rev parse command. That's one way to see. Okay, it gives us this big long SHA is what it's called. So a SHA is short for secure hash algorithm, and it's a way to take some text and apply and basically run this secure hash algorithm on it and get a unique representation of that text in a how long is that? I think it's 40 characters on here. Let me confirm that. So if I echo that and use word count, okay, yeah, so it's 40 characters plus the new line. So this is a 40 character unique and reproducible, just a string. It's I think it's all hex characters. So because it's reproducible, you can use that to you can use it as an address. So I can take any file like this, commit, and you may have heard of MD5 sum, or MD5, I guess it's. And so that takes the contents of commit and it runs it through this MD5 sum algorithm, hashing algorithm, and comes out with the same thing every time. And if I change it, it comes up with a different same thing every time. So SHA is the algorithm that Git used way back in the day. It still uses. They're trying to change it for reasons I'm not entirely sure of, but it works great for taking some content and attaching a 40-character address to it and being able to reference it via that address. So if you recall, we looked at the Git objects directory.
Is the SHA unique to a particular set of combinations, or could it be possible that two different files just through luck would come up with the same SHA?
It is theoretically possible that would be the case, but it's less likely than, you know, the number of atoms in the universe or something like that.
Okay.
So for all practical purposes, the SHA-1 algorithm does what we want. There is an example, I believe, of a team, some you know, high-end crack team of scientists was able to produce a SHA that referenced two different contents, but they had to work very, very, very hard to do that.
Okay. All right.
So we're good. Long story short, yeah, I mean it's SHA-1 was used for security. So secure is kind of, you know, quote in quotes these days. But for Git purposes of addressing, it's you know, pretty much everything we could want. So I think, you know, I don't know exactly who it was. It's no longer comfortable with, you know, SHA being used for Git addressing, but there's a working group to change SHA-1 to something else, but it's going to be a while.
When you're saying SHA-1, I've heard of, like, or maybe I'm mixing it up. SHA-256, like normally when I download another copy of like a Linux operating system, you know, you want to double check that those 40 characters match just to make sure you downloaded it all correctly and you're not missing any files. Is that similar or same name or different?
It's an evolution. Yeah, it's better, and that's all I know about security, pretty much. So, you know, what we want to focus on here is just is its purpose for addressing, and that's completely separate from security, if that makes sense. So for addressing, it's plenty good enough. So what we have is basically a whole just a two-level directory of SHAs. That's what the Git database is. So for instance, this SHA here, we can find it in here, and the way we find it is by taking the first two characters, this FC, and looking for it in this objects directory. So rather than going cross-eyed looking across here, I just type FC, and sure enough, there's something in there. And what's in there is the rest of that SHA, right? So this part here is what's in there. So what is that? Let's poke around a little bit and see how much we can find out about that. There's a Linux command called file that it makes a try at telling what kind of file you're looking at. So we could try that. Sometimes it's not very successful. It thinks this is a VAX executable, which it's not. But it's enough to know that it's not ASCII, right? It's some binary format, which is fine. That's what Git does. It compresses content first and then runs the SHA on it. That may not be entirely correct, but it does store it in compressed format. So, but that's okay because we have some commands that can look at it anyway. So cd dash to go back where it was. So before we do that, let's look at a couple of examples here. This might sink the concept in a little further. So we can actually use some Git plumbing commands to do what Git does under the hood. Some of these you won't use in real life, but it's handy for seeing what's going on with Git. So one of those is this hash object command. So let's just run through this set of commands here and see what's going on. So I'm echoing the text hi there into this file, redirecting my standard output into a file, using cat to look at it. Sure enough, there it is. So now we can see what kind of address would get attached to this file. We could use hash dash objects, give it the file name, and you should get the same result if you do this, and if you've typed the same content into the hi.txt. Now notice it's just the content, it's not the file name, right? If I rename it and then do it again, I still get the same value. So it's only the content of the file that's getting hashed. But I haven't actually put it into Git, have I? Because if I look under 41, in my Git database, there's some stuff there, but not this. So hash object is only spitting back a hash. It's not putting it anywhere for me. I can give it a, you know, an option to make it do that. If I give it -W, suddenly now it is there, right? Now it did go ahead and there's the rest of my hash that matches up here. So now it's actually in the Git database. Can't do much with it yet, but it's there. And I can't cat it and look at it directly, but I can git cat file it. So there's another plumbing command. And I want to give it a little bit of the SHA. I don't have to give it much, just the first 4 characters. As long as it's distinguishable from the rest of all these guys here, the first 4 characters is enough to tell it what I'm referring to. And I need one more option, -P for print. Git cat file -P. And so git cat file, you know, unpacks, it's another plumbing command. It unpacks that thing and tells me what's in there. And I'm able to do that because git cat file looks in the Git database, and because I put it in the Git database with this -W, now I can get it back out. Any questions so far about SHAs and addressing Git content with SHAs? Pretty basic, like low-level stuff here. Promise it gets more interesting. So now we've been able to hash an object, we've been able to put it into the Git database, and now we can sort of build out from there, okay? So let's see, is this gonna be, let me back off and let you do this part here. Commit, so take hi.txt and commit it using the Git commands you normally would use. Like put it in, you know, commit it into what we've got here. So you should see another commit of yours. You know, once you're done, when you type ADOG, you should see your commit up at the top of this history. So, oh, by the way, you can hit Q to get out of this if I haven't covered that already, of your ADOG view. So let me give you about 5 minutes-ish to give that a shot and explore some of this these concepts here. So 9:59, 10:05, we'll go back through it.